Right. So let's try another problem. Oops. An object travels from point A to point B in 4 seconds. Then it travels from point B to point C in 5 seconds. Find the following. Velocity from A to B, velocity from B to C, velocity or average velocity from A to C. Okay, and the picture looks something like this. A, B, and then C is somewhere there, and then there are some distances involved which are not, I didn't write it down in the question, but here they are in the picture. Okay, so that is 5 up to here, goes A, B, C. This is 5, this is 12, and this is 17, all in meters. Usually when I draw the picture, I don't like to clutter up with units, but here let me write a note. All distances are in meters. And then there are some angles that are given. So that's 40 degrees. Okay. All right, so let's work this problem. So first is velocity from A to B. Okay, so which is straightforward. Velocity from A to B is just that distance A to B, or the displacement, you can say, or distance. In this case it's the same, it's a straight line going from A to B divided by the time. So I'm going to write velocity A to B is equal to, what's that distance? That is square root of 5 square plus 12 square divided by what's the time? 4 seconds. 4 seconds. So 5 square is 25, 12 square is 144, 169. So that's 169. Square root of 169 is 17, I believe. Let me check it. So, square root of 169, yeah, oh sorry, that's 13 divided by 4. 13 divided by 4, 3.25. 3.25 meters per second. Okay. So, and then for the angle, that's the angle. Okay, you can say that's the angle. We can also find the angle. Let's go ahead and do that. So the angle would be, or you could even say the vector is at a slope, and you can give the rise over run like this. You can say, right? You can say at 12 by 5, right? The rise over run. So that also establishes the angle indirectly. So you can either give it that way, or you can find the angle and do it. Okay. We're going to do, so let's do the B part. You can also do the angle if you like. It'll just be tan inverse of theta is tan inverse of 12 over 5. Yeah. Or you can do, you know, you can do it like that. All right. Going to the next part, which is velocity from B to C. Again, this is really straightforward. In this, you don't even have to calculate the distance. 17 is already given. So velocity B to C is 17 divided by 5 seconds. That's all given. So you get what? 3.4 meters per second. Right? So that's all good. Now coming to the third part, average velocity from A to C. So average velocity from A to C, to find that we need to first find the distance from A to C. Okay, how do we find that? We will use the law of cosines. So I'm going to write down the steps of, I'm going to write down the thought process. Okay, so to find velocity AC, find distance AC. Then if you have the distance, then you know the time, which is the time it took for the entire journey, 5 seconds plus 4 seconds. So this AC distance divided by 9 seconds is the answer, but we need to find AC. How do you find AC? We have, so this is 13, we just found out, right? Square root of 5 squared plus 5 squared plus 12 squared is square root of 5 squared plus 12 squared is 13. Okay, so how do you get the distance AC? So use law of cosines, right? So to find law of cosines, you need the two sides and you need the angle between them, right? If this is ABC, right, we have BC, we have AB, but we don't know this angle. So let's find that angle. If this is 40 degrees, then that will be 50, right? And if that is 50, all we need to do is find this angle. Okay, how do you find that angle? You can find that angle from this triangle, from AB, let me call that D, from ABD, right? Find angle ABD. Okay, find angle ABD. Okay, which is simple. ABD, 12, 5, 13, right? So I'm going to call it alpha. Alpha, sine alpha is equal to 5 over 13. Alpha is sine inverse 5 over 13. Alpha is what? Sine inverse 5 over 13. 22.6. Okay, so we have 22.6 and then 50 degrees there, so the entire angle B is what? 72.6. Okay, so I'm just going to draw that part here. 72.6. This is A, B, C. We need to find AC. We know that is 17 given. We found out this is 13. Of course, this is not to scale because in my diagram 13 is somehow much longer than 17. Doesn't matter. So using law of cosines, what do we have? Let's call that D. D square is 13 square plus 17 square minus 2 times 13 times 17 times cosine of the angle between them, 72.6. See what we get. Okay, so I'm just going to calculate D here. So I'll start off with the square root of 13 square plus 17 square minus 2 times 13 times 17 times cosine of 72.6. So I'm getting 18.05. Okay, 18.05, right, meters, which is, I calculated D directly instead of doing D squared and then doing the square root. So okay, All right, so we know the distance and we know the time, because the time, even though this object traveled from A to B, B to C, this took 5 seconds, this took 4 seconds, the overall time is 9 seconds. So velocity AC is average velocity, right, is 18.05 divided by 4 plus 5, 9. Let's round it off to 2 meters per second. 2 meters per second. All right. So now we need to find the angle. We need to find that angle. Okay. Let's call that beta. You can either, so because this is the vector we're interested in, we can find, so actually this is the angle we should be, so this is the angle we're interested in, but there's no direct way of knowing this angle. Let's call that gamma. There's no direct way of knowing this angle. That's why we've got to find beta first, this angle, right? And then we can find this angle, right? From here, okay? From here, okay? So right now it's a simple matter of geometry. So if we find this angle and then subtract it from this angle, which we can find from that triangle, then we get this angle beta. This angle beta, this angle gamma. All right, so let's go about it. To find beta, we need to use law of sines, right? So sine beta divided by the side opposite to that, 17, is equal to sine sine 72.6 divided by the side opposite to that, which is D, which is 18.05. Okay, so beta is equal to sine inverse of, and then I'm going to put all of that within it, sine, so 17 times sine 72.6 divided by 18.05. All right, let me do that. So sine inverse of 17 times sine 72.6, then divided by 18.05. Okay, so I'm getting beta as 63.99. I'll call it 64 degrees. So this is 64 degrees, beta is. Now we need to find alpha, which is, go back to the triangle ABD. We found this to be 22.6, right? Was it 22.6? Yeah, 22.6. This is, of course, 90 degrees. That whole angle is what? 90 minus 22.6. So 90 minus 22.6 is, this whole thing is 67.4. And out of that, right, this AC is going like that. Okay, so I'm going to reconstruct that. Right, so this angle we found as 64 degrees, right? So this would be, if we use another color, that angle would be what, 3.4 degrees. Okay, so you can say AC is what? What's the magnitude of AC? Velocity AC is 2 meters per second. 2 meters per second at an angle of 3.4 degrees from the horizontal. Okay, so this is the problem. It looks tedious, but it's actually, well, it is tedious, but it is the concept is simple. It's just a lot of simple calculations, like for example, we just want to find out the velocity A to C. So we need to find the distance A to C and divide by the total time. To find the distance A to C, there's a little bit of a geometry we got to do. So that's why it looks tedious. The geometry part looks tedious, but in terms of concepts of dynamics, there's not a whole lot here. Okay, so just go over the problem, make sure I didn't make any arithmetic mistakes. So this is how you do it.